Okay, so given this differential equation, we want to find a y that is a solution to it. So the first thing I'm going to do is I'm going to just rewrite a few things here in a different notation. And I'm going to rewrite this portion here. Okay, so now what we need to do is get this into a form where we can find the integrating factor. So what that means is we have this extra term here in front of the dy dx. We need to get rid of that. So we're going to divide every term by that term. Okay, the next thing that we want to do is notice that this part in front of the y term is going to be used in our integrating factor, and also that this entire left-hand side here is the output of the derivative product rule. So what that means is we can rewrite this entire left-hand side as notice I'm putting a prime there. And we're just not going to worry about the right-hand side for now. So what's really nice about what we've done on the left-hand side here is this entire portion here is like an input to a derivative function, and the output is that underlined blue portion above. And these derivative and integral operators will cancel out. So our entire left-hand side is going to be written as okay, now let's evaluate this guy. So that is going to be e to the 2ln 1 plus t squared. And using power rules, we can move this 2 up into here and square the input. And anything, and we know that e and the ln cancel out, so what we'll have is, okay, so this guy here is our integrating factor that we'll use on the right-hand side. So, oops, let's use white here. We're going to bring down this portion. And we're dividing by that. So what you will have, or I'm sorry, multiplying, because we're not simplifying the left and right-hand side. We still haven't multiplied the right-hand side by the integrating factor. And then this will simplify too. Cool. Okay, and so now we will integrate it. And what we'll end up with is, don't forget the constant. Now we can divide this guy here, we can divide that term out. So what we'll end up with is y okay, and so we can verify this. Our original function was, put that back in prime notation, and then multiplying by this entire function in there, and that would equal to, what was it? It was like 1 plus t squared to the negative second, but we like to write it like this. Okay, so normally we would verify it by plugging this in and then taking the derivative of this entire thing for the y prime. The thing is, that can be pretty ugly, trust me. I checked that in a calculator. If you were to do that by hand, you'd be wasting a bunch of time. We can actually just graphically verify this. So let's hop over to Desmos, and I will show how we verify that. Okay, so the first function, f1 of x, that was our y that we just found. The blue expression is our differential equation, and then the green portion, the y, that is our right-hand side of the differential equation. So we're just comparing the left and right-hand side of the differential equation for if they overlap with each other. So as we can see here, if I deselect one, you can see that these are perfectly overlapping. Now, I chose an arbitrary constant of 1. However, if you change this to whatever constant you want to pick, you will notice that those two overlap, and that shows that we have the correct solution.